Hello everyone, today let's solve the problem looking for order. So this was asked in the Codeforces beta round 8, right? So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So what the question states here, we have to start and end at the handbag, nothing but the point zero, right? So we have to start and end at the handbag. Just give me a second here, 1 second. Yeah, we have to start and end at the handbag in the sense at point zero. Just remember this one, we have to start and end at the handbag at the point zero, right? Each trip you can carry at most two objects, right? So each trip we can carry at most two objects. So each trip we must we can carry at most two this one objects. Just remember this one, right? So once picked, we must go straight to the handbag, right? Once we have picked, we must just go straight to the handbag. We cannot drop anywhere or elsewhere, right? Travel time between 2 points is nothing but squared Euclidean distance, right? So travel time is between the 2 points is equivalent to the squared Euclidean distance, right? I'll just write here ed, right? Euclidean distance. What we need to find here then, we have to find the minimum total time and output one optimal path as a sequence of indices, nothing but handbag equals 0, right? Again we have to find the minimum total time and the output one optimal path as a sequence of the indices, right? That's what we need to do, minimal time as well as one optimal path. Just remember what we need to find here, minimal time or the minimum time and one optimal path, one optimal path, op I'll keep here, one optimal path, minimal time and one optimal path we need to find. So again, let me read the question for one last time. So we have start and end at the handbag, nothing but the point zero. Each trip we can carry at most two objects, right? Just keep this in mind, this is very important, right? So this is fine, at most two objects, right? So once picked, we must go straight to the handbag. We cannot drop elsewhere. So travel time between 2 points is equivalent to this one. This we will be using initially itself. Just remember this one, right? Travel time is between the 2 points is equivalent to the squared Euclidean distance. We have to find the what we need to find. We have to find the minimal time and this one optimal path as a sequence of indices, nothing but when handbag equals 0, right? So this one is fine one. Let me delete this one. Yeah, now let's do one thing, let's go with the approach, right? So let's go with the approach, or let's do one thing, let's discuss the input output part, and then let's hop into the approach part, right? So now here we have sn objects given, we know this one, right? So input output, this is nothing but the s, right? Accordingly with the question, this is nothing but the s, and this 1 1 and minus 1 1, this is nothing but the this one objects. We have been given two objects, they have mentioned that we have been given two is nothing but number of objects, right? So 1 1 and minus 1 are the two objects, basically this is nothing but s. So the output that we need to get here is 8, minimal time is 8, and this is nothing but the minimal time, and this is nothing but the path, one optimal path they have asked, right? So this is nothing but the optimal path. Okay, I'll just read. The same goes with this one, next input as well. This is fine. So let me delete this one entirely, right? So as we are completely familiar with the question and the input output part, let's do one thing, let's quickly hop into the approach, right? So let's discuss the approach followed by the complexities, and then let's write the code. Initially, as usual, let's discuss the approach first. So I have considered the same first example that they have given in the question, right? So this is nothing but the s. We have discussed this one already. So this is nothing but the optimal. Uh, so what do we call this? Mm, yeah, uh, this one is 1 second. Just give me a second here. 1 second. We have to go with, yeah, this is nothing but the objects basically, right? Two objects basically, right? So I was thinking some other thing. Sorry. This is fine. Now output that we need to get here is 80120, right? This is nothing but the minimal time, min time, and this is nothing but the optimal path. This one is nothing but optimal path, right? So this is fine. Now let's move on with the step-by-step explanation. Before the explanation part, let me tell you one thing. So we will be making use of the dynamic programming, right? Along with the bit mask, right? Bit mask, in the sense, we know we have already solved the problems on the bit manipulation, right? So many problems we have already solved. So nothing but bit mask, in simple terms, nothing but masking the values, in the sense, either we can change, we can modify, or just to keep the value, right? So we will be masking certain value. That's what basically bit mask does, right? So we will mask the particular value just to keep this one, just to keep, change, or modify, right? Within the particular this one, whether it may be in the problem, whether it may be anything, right? So this is how we make use of the bit mask. We will see that one in the code, or in the further part, right? So let's move on with the further things. Now first, initially we have considered the same thing, right? S we have 0 comma 0, and this one, two objects we have. First object 1 comma 1, and the second object we have minus 1 comma 1. This one I'm speaking of. First object, this one is first object, this one is second object, and this one is S we have 0 comma 0, right? First, what we'll do, we will pre-compute the square distance, right? So first we will go with S comma 1, right? 1 square plus 1 square will lead to this one, what do we call, uh, 2 basically, right? This one will go with 2, second object, right? So this one basically, this one will lead to 2 as well, right? So basically 1 comma 2 will lead to 4, right? 1 square plus 2 square, square root of 1 square plus 2 square. So this one has to be in the positive value, so this will be 2, 2, and 4. Now we have the computed square distance. I hope you know the this one, Euclidean formula, right? Square root of this one, 1 square plus 1 square, whatever I have calculated here. So this is based on 1 comma 1 minus 1 comma 1, this one, right? So finally we went with distance, right? So distance of 1 comma 2, that is nothing but 4. 1 square plus 2 square. So sorry, this one will be uh, this one 2 square basically, right? So this one will be 4. This is fine. 0 square plus 2 square, so this is fine. Now let's go with the state and goal, meaning, so we have to mask, or mask has bits for 0 1 2. See, so we have the value 0 1 2 here, right? So we have the value 0 1 2 basically, right? So see here, object 1 2, we have the value we have here is 1 minus 1, this one 0 1 minus 1, right? So mask has bits for 0 1 2. So bit 0 handbag is always set, right? So we know this from the question. Start mask is nothing but 0 0 1, which is equivalent to the value 1, right? We will be stopping when bit count nothing but mask equals 3, that is mask 1 1 1. So binary representation and 1, this one is 1 1 1, and in the numbers that is nothing but 3. Same goes with 0 0 1. So this is nothing but 1, right? In the integers or the numerical value, binary representation is 0 0 1. So mask has bits for 0 1 2. Bit 0 handbag is always set. We will start mask. Now we have 0 0 1. We will stop when bit count nothing but mask equals 3, right? So this is fine. Next, what we'll do, first we will be going with at mask 0 0 1. So we have to go for 0 0 1. Just give me a second here. 0 1 1 and 0 0 1 we need to go with, right? So I hope this is clear. So 1 and 3 basically we are considering for. So now we'll pick the first undelivered, nothing but I equals 1, right? So we will try all the j that is not delivered. So first we will take one item, nothing but solo, I equals 1, j we will consider 1 as well here, right? So trip cost is s to 1 plus 1 to 1 plus 1 to 5. Nothing but s to 1 is nothing but 2. We have already got the values. Previously, you can just see. And 1 to 1, this is nothing but 0. That is how we got 2 square, that Euclidean distance for 1 comma 2. 4 we got, right? So here in this case, it 1 to 1, this is nothing but 0. And finally, we have 1 to 5, nothing but 2, right? So we this one, we have to go with the solve of 0 1 1. Solve is nothing but the helper method that we'll be making use of within the code. This one will be basically 4, right? So 2 plus 0 plus 2 is nothing but 4, right? So this one will be solve of 0 1 1. So at mask, this one 0 1 1, only two items left for us, right? So now first undelivered I equals to 2 and j we will be going with 2. This is solo, right? So new mask will be 1 1 1. So trip cost we will be considering for s to 2, from 2 to 2 and also 2 to s. So this will be again 2 plus 0 plus 2. So this will lead to 4. So previously we have got 4 and now also we have got 4, right? So we will be going with the solo. Total is nothing but solo plus solo, right? So this will be 8. 4 plus 4 will lead to 8 basically. This is fine, easy, right? So we have put those two things together. Now we will take two items together, nothing but pair, when j equals 2. So new mask will be, we will be considering 0 0 1 0 1 0 as well as the 1 0 0, right? 1 0 0. So this will be what do we call 1 1 1, right? So we are going with the or. So either of the so if a and b, either of this thing 0 0 0 1 1 0 1 1, if either of the a or b is 1, then it will be 1 here in this case, right? So this will be 1 1 1, so this will be 0, right? So in this case this will be 1 1 1, right? So trip cost will be s to 1, 1 to 2 and 2 to 5. So this will be again this we have, this we know s to 1 is 2, this we have already calculated. 1 to 2 is nothing but 4. This also we know, we have already calculated 4 and 4 we got, right? So 2 to 5 we know this one, this is nothing but 2, right? So 2 plus 4 plus 2 is nothing but here in this case 8. So again solve of 1 comma 1 comma 1, so sorry 1 1 1, this is nothing but equivalent to 0, right? This is equivalent to 0. So total via pair ones, we are considering the whole pair, right? So total via pair ones, we will get the output 8, right? So DP choice we will be going with 8 comma 8. So minimum time we need to calculate along with the path, right? So minimum time we have already got the 8 from the previous step, 8 and this 8 pair once, this one also will be considering. So 8 comma 8 minimum will be considering. So either we can consider any 8, right? So this is fine. Minimum time that we got here is 8 and we have to go with the path reconstruction, right? So that path, the trace, we'll be making use of one more helper method here to trace. We have to trace, right? So what we need to trace, let's see here. The trace tries j equals 1 before j equals to 2, right? So the trace tries j equals 1 before j equals to 2. So it often picks the solo, right? So it often picks the solo route and points basically, right? So this one will be 0 1 0 2 0, right? Two trips we are considering, right? So it again, it often picks the solo, right? So we will be going with 0 1 0 2 0. This is for the two trips. And if it picks j equals to 2, it prints pair route. Pair route, we just this one we went with a pair route. This is nothing but the third step, this is nothing but the paired route basically, right? So just remember this one. Just give me a second here, 1 second. Yeah, now 1 second. Yeah, if it picks j equals to 2, it prints pair route, right? So in this case, we will get 0 1 2 0, one trip that is carrying 2. So we can just consider this one itself, right? 0 1 2 0, 0 1 2 0. This is for the two trips, and this one basically it picks j equals to 2, it prints pair route. So it is better to go with a paired route, right? So the answer will be, one optimal path will be 0 1 2 0, right? So they have asked for the optimal path, so we'll be going with the one that picks j equals to 2, which consists of the pair route or which prints the pair route, right? So we will be going with 0 1 2 0, one trip carrying 2, right? So this is fine. 0 1 2 0, this is fine, man. So both are optimal and with a total time 8, total time 8, 8 comma 8, right? So both are optimal and comes with a total time 8. So we can consider any one, this one 8, and we will be going with the optimal path 0 1 2 0, 0 1 2 0, right? So the output that we got here is 8 0 1 2 0, which is equivalent to the output that they have given for the example one within the question, the 8 0 1 2 0. This is fine. I hope the this one approach part is completely clear, man. As we are completely familiar with the approach part, let's quickly discuss or let's quickly move on with the complexities part. Just give me a second here. So yeah, complexity. So what will be the time complexity, overall time complexity here? The overall time complexity would be big of n square into this one 2 to the power of n. So why here it is big of n square into 2 to the power of n? Because we are going with the n square into 2 to the power of n states or the transitions, right? So we are picking the first free, or we have already, right? So we had picked the first free I per state, and we are trying all the j. So we went with j equals 1, j equals to 2, and we went with pair route as well, right? So we picked the first free I per state, and we are trying with all the j. So implemented with a dp table of size 2 to the power of n plus 1. So overall time complexity would lead to big of n square into 2 to the power of n. So what will be the space complexity here? The space complexity would be big of 2 to the power of n. So when I say the space complexity would be big of 2 to the power of n, right? So integers per dp, right? So the space complexity would lead to big of 2 to the power of n integers per dp, technically 2 to the power of n plus 1 entries due to the bit 0, plus big of n for the coordinates, right? So overall space complexity would lead to big of 2 to the power of n. This one will be space complexity, and this one will be time complexity, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square into 2n and big of 2 to the power of n respectively, right? So this is fine, I guess. So now, as we are completely familiar with the complexities and the approach part, let's quickly uh, start writing the code, right? So let's start writing the code here. So I'll just come to the compiler. So one thing, what I need to tell you. So this is fine. Let's move on with the coding part, man. So let's go with the input output part. I'll just go with import java io. So as we'll be going with the fast input and output, so let's import the input output package. So we'll be going with the different utilities as well. So I'll just go with the import java dot this one util dot star. This is fine. Now next let's go with the class. I'll just go with class name. So I can just give any class name that is relevant to the problem. So let's go with the number of objects plus first. So I'll just go with static here, this one int n. So next let me go with static again. So this one we need position as well, right? So I'll just go with position. So also we need the dp array, nothing but dp of mask will be going with, right? So dp of mask within the array is nothing but minimum time from the picked set state. So I'll just go with the dp. Just for now, let's go with the this one initialization part. So I'll just go with int here. So this one will be dp. This is fine. Next, let's go with the fast output. Nothing but I'll just go with static here. So this one will be print writer. Let me call out. So this is fine. Next, as we had discussed in the approach, if you remember the approach, so we have to go with a squared distance between the points that is indexed A and B. So we have to go with a Euclidean distance, right? So or Euclidean the formula basically. So for that, let's write the helper method. This one distance. I'll just go with int dist. So let's go with the parameters a and b. So we have to find the distance between a and b itself, right? So by squaring them. So this is nothing but parameters a and b. So next we'll be going with the this one dx and dy, right? So dx is the distance between a and b, and dy is the distance between again it's a and b based on the this one values, right? So I'll just go with here this one, not the values, horizontal and vertical. This thing dx will be position of a 0 minus position b 0. This is fine. Next dy will be position of a 1, position of b 1. So this is fine. Yeah, dx dy position, this one distance between a and b respectively. Now we have to go with the squared Euclidean distance, nothing but the time cost. So we have already discussed this one. Let me write this one quickly. This one is nothing but dx into dy plus dy into dy, right? So we need to consider positive value always. Just remember this one. This is fine. Now as I've said, we'll be going with a bit mask dp, right? So we have to mask that includes bit 0, nothing but bit 0 in the sense we have already discussed this one in the question, nothing but this is handbag bit 0. We are masking that includes bit 0, nothing but the handbag, that's always set, right? So that's always set. And 1 to n indicates delivered objects. Just remember this. Now first let me let's go with the helper method solve first. So let's write the main logic within the solve. So I'll just go with static int. So this one, let's go with the solve. Let me consider the parameter mask here. So within the mask method, if all n objects are delivered, then bit count is nothing but n plus 1, because bit 0 is always set, is not always set, is already set, or it's also set first itself, right? So this is fine. Now how can we articulate that one in the form of code? So this one we can write if integer dot bit count of, we have passed mask already as the parameter, if it is equal to the value n plus 1, then we just have to return 0 in that case, right? So this is fine, man, right? So now we have to return the memoized answer if present. So this one will be if dp of mask, so if it is not equal to -1, then what we need to do, then we have to return dp of mask. So this is fine as well. Now let's do one thing. Let's go with the large initial values, which acts as this one, positive infinity, right? So I'll just go with int result equals, let me make use of int here. This one is 1 into 10 to the power of 9. I can just write here 10 to the power of 9 in this way, 1e9, right? So this is fine. We are just going with a large initial value, which acts as positive infinity, basically. This is fine, man. Now let's pick the first one, that is not yet delivered, nothing but object I, right? So let's write this one. Uh, it's nothing but the, this one, what do we call, iteration part, right? So we have to do it for everyone, everything. Nothing but we have to pick the first non yet delivered object I, not yet delivered object I. So let me go with for loop here. This is fine. And I equals 1, I less than or equal to n. So I plus plus. So within this for loop, we have to mask, means if I is not yet delivered, then I'll just go with if. So this one will be mask, and uh, we are going with a bitwise end here, along with the left shift operator for masking, right? So this is fine. We already know, right? And operator, what it does basically, if only I this one, when a and b both are 1, then only the resulting value will be 1, right? Or the, then only then the resulting value will be boolean value true, basically, or 1, right? And the left shift operator, it shifts the operand left, right? We know this one. So now if the value, this one, if it is equivalent to 0, means if I is not yet delivered, then let's try pairing I with the j, right? Not yet delivered, right? So let's try to do that. So within this, what I'll do, I'll just write one more for loop, right? So I'll consider j here accordingly with the approach. So I'll just go with int j equals, so we have to start with 1, not 0. Same thing, j less than or equal to n. So this one will be j plus plus. So this is fine. Within this for loop, again we have considered if I is not delivered. Now we have to go with if j is not delivered, right? So let me copy the same thing here, this one, and make the necessary changes. Only thing that we have to change here is this one, from I to j. Other things remain same if j is not yet delivered, right? So this is fine. So within the if condition, what we'll do, let's go with the new mask after delivering I and j. So this one I'll consider new mask, that is equal to mask, or I'll just go with 1 left shift I. So this one is fine. 1, this one j. This is fine, man. So we are considering the new mask after delivering I and j. So now let's do one thing. Let's go with the cost of one trip, nothing but 0 to I and I to j, then j to 0. With I that is equivalent to j, the value I'm speaking of, and middle hop is 0. Right. So let's try to implement the same thing in the form of code. So I'll just take the variable name cost here. This one we have already written. This one. Let's go with the recurse. Let's go with the recursion, or let's recurse here. So this one will be solve of this one, new mask basically, and also we need distance, right? So I have considered distance already. So this one from 0 to I, this is fine. Also same thing, let's do for j as well. Distance from 0 to j, or uh, we have to go from j to 0, not 0 to j. This is fine. Yeah. Now we have to keep the minimum over choices of j, nothing but result equals here. So we have to consider minimum. So minimum of 8 comma 8, we got any in that case the same number, we can consider any either of them, right? So this is fine. So this one we have to consider result comma cost. So we have to keep minimum over choices of j. So that is the reason we have written code in this way. Now we are done with this part almost. So let's break, because this is nothing but the for the crucial optimization. We are only branching on the first free I, right? So to avoid the permutations. So I'll just go with break here. This is fine. Let me come out of this one entirely. Now we have to memorize and return, right? So I'll just go with all we all we need to do is return here. So this one will be mask, dp of mask. Let me assign this one to the result. So let me come out of this one entirely. Now let's do one thing. We have to reconstruct and print one optimal path, right? So this one is nothing but one more thing. First thing, we have to print the minimal time. So that we have done here within the solve method, right? So now one more thing, after printing the minimal time, we have to print the optimal path, right? 0 1 2 0. If you remember, 8 was the minimal time that we got in the output, and 0 1 2 0 was the optimal path. So we have to print the optimal path as well. That now we will do with the one more helper method accordingly with the approach that we discussed, right? So this, what we are doing now, we are reconstructing and printing one optimal path by following the choices that achieve dp of mask, basically in simple terms. So I'll just go with static here, void trace. Let me pass mask here. So this is fine. If this one integer, mm, dot, let me go with a bit count. So this one of mask, if it is equivalent to n plus 1, then we don't have to return anything. So I'll just give return here. Means all objects are delivered. We have to stop when all objects are delivered, right? So this is fine. Next, let me assign best to the dp of mask, meaning the optimal value from this state, right? So we have to consider we are considering the optimal value from this particular state. So I'll just go with here best equals dp of mask. This is fine, man. So let's write this one quickly. So again, we have to pick the first free I and try all the j to find the move matching best. This is similar to the previous step that we had done, right? So this one again, we will do the same thing, right? So I'll just copy the same thing here. This one where, so see here, this one for int one, this one new mask until this one. What do we call? Didn't we return anything previously? Uh, we did return. So until, so I'll just go new mask we are doing here. This one is also fine. And so until here, let me copy. This will be same, I believe. Let's see. So here, what we are doing basically. So one, two, three. Just give me a second here. One, two, three, four. We have given, right? So this is fine. So I'll consider here 1, 2, 3 brackets 4. This is fine, right? So just give me a second. I'll explain one by one. So this for loop, what it does, again, we know this one, man. I don't have to explain, right? So this one is if mask so we are going with for loop, right? I equals 1, I less than or equal to n, I plus plus. So this remains same. Mask, and we are going with a bitwise AND operator and left shift operator as well, right? So we are just masking with a bit 0, basically hand back. We have discussed this one. If it is equivalent to 0, we have discussed this one already. I'll not discuss this one again. So for int j equals 1, so this j less than or equal to n, j plus plus, this remains same. mask and same again left shift operator along with this one bitwise, and we are going with the handback value nothing but 0. This one is nothing but new mask, or this one left shift operator I and j. This remains same, but this is nothing but the state after taking I and j. So this one I have already said this one, right? Now we are going with the cost nothing but solve again. So we have made use of the helper method solve within the trace method, right? So see here we are making use of the solve we have already written that, we have already written before the previous one, right? So the previous method, this one I'm speaking of, this one solve we have already written that one. So we are making use of that one within the this one trace method, right? So this is fine. Solve of num plus distance of 0 comma I plus distance of j. This remains same. Now from here what we will do, first let's go with one more if condition here, nothing but this of I comma j, if it is an optimal path, right? So in simple terms, if cost this one is equivalent to the value best, if it is the optimal path, then what we need to do basically, so we always start a trip at 0 and go to I, right? So we need to print on this way out dot print. So this one as I've said, we always start the trip at 0 and go at I, right? So 0, this is fine, I'll just leave one space here. So this one, let's append I along with the this one. Let me leave one space here. This is fine. Oh, this is fine, man. Next, let's do one thing. If we took two items, then we also have to print j. Meaning, if I not equal to j, then what we need to do? Let me print something. Out dot print here j plus. So this one, let me leave space here. This is also fine, man. Finally, let's continue reconstructing from the next state. So this one will be trace. In simple terms, we are recursing here. So this is fine. New mask, trace of new mask. Finally, we'll stop after printing the first optimal branch. We don't have to return anything. I'll just give return here. This is fine. So now, yeah, we are done with this one, right? This one is fine. We are done with the trace helper method. Now we are left with only one thing, the main method, right? So along with the input output. So I'll just go with main here. So let me remove this one quickly. So let me add here exception as well, or else we'll get the error, or else it will throw the error. So I'll just go with throws exception. This is fine. Within the main method, the first step is let's go with a fast input reader. So I'll just go with fast scanner. Uh, Let me consider the variable name fs here. New fast scanner. So this one will be system dot in. This is also fine. The next one is let's go with the fast output writer. So I'll just go with out equals new print writer. So this one will be system dot out. This is also fine. The next step is let's go with the handback coordinates. Nothing but here in this case sx equals. So this one will be fx dot next int. So I'll just go with next int here. Sy equals fs dot next int again. So we are just going with the sx and sy. Nothing but the handback coordinates here. So next let's we have to go with the number of objects accordingly with the input. So we had two objects for the example, right? So we have to consider the number of objects, right, accordingly with the this one input part. So n equals, I'll just give again fs dot next int. So again everywhere I have given small I here. Let me make this one capital one, or else we'll get the error basically. Let me turn this one to capital I. Again, let's turn this one to capital I. This is fine, man. Now, let's do one thing. Let's go with the position. So I have already considered POS. This one will be new int of n plus 1. So this one will be 2. This is fine. So we are just allocating the positions array 0 to n. So now let me go with position 0 of 0, 0, 0. This one sx. This is fine. position of 0 comma 1. So this one equals sy. This is also fine, man. Let's go with a for loop here. This one int I equals 1, I less than or equal to n, so I plus plus. So within the for loop, what I'll do, let me go with position of I 0. We assign this one to fs dot next end. So this is fine. The same thing, let's do it for next one as well. So I'll just go with position of instead of I0, I'll just go with a I1, right? So the same thing. So this is fine. Next, what we need to do, I'll just come out of this one for loop actually. So now, as we had discussed earlier, we have to go with the DP that has 2 to the power of n plus 1 states, right? So because we are including the bit 0, nothing but handbag, we mask that one as well, right? So we are including the bit 0 as always set. Also, um, we are initializing to -1, right? Also we are initializing that one to the -1. So I'll just go with the dp equals new int of this one will be 2 to the power of n plus 1. I said this will be n plus 1. So 2 to the power of n plus 1 in the sense new int of, so here let me write 1 left shift operator n plus 1. So this one is fine. This n plus 1 has to be within the parenthesis, not the array, right? So this is fine. Next, we have to initialize this one, or we have to fill initially with the -1, right? So I'll just go with arrays dot fill. Let me pass dp and -1. This is fine. Simple. Now let's start with a mask that is equivalent to 1, meaning if we are setting only bit 0, that has been already set, nothing but the handbag, right? So we just have to print the minimal time first. So to print the minimum or the minimal time first, so I'll just go with out dot print. Let me go with a print ln. So because we have to go to the next line, right? After printing the minimal time, we have to print the optimal path as well. So I'll just go with solve method we have already written. I'll just make use of the solve method, solve of 1. So this will print the minimal this one minimal time or the minimum time. So we also have to print the valid optimal route or the valid optimal path, meaning trace will print the lex like this one 0 I j for each trip. So that is the reason we have written this one trace method, right? So the optimal path, it gives the optimal path. So the minimal time will be given by the solve method, and the optimal path will be given by the trace method. Both are the helper methods, right? So we have already written that one, so I'll just make use of the trace here, trace of 1. So this is fine. Finally, what we will do, we have to end at the handbag, nothing but final 0, meaning I'll just go with print here. So this one will be 0, right? So finally, let's flush and close the right. You can just go with a flush or close, right? So I'll just go with close. For the previous problem, I went with flush. For this problem, I'll just go with a close, right? So this is fine. So we are left with only one thing. See here, we have made use of the fast scanner. So I'll be making use of the custom fast scanner, right, method. This is related to the input output, strictly input output. So this is not related to any logical part is done. We have printed this one. We have calculated first minimum time, and for the trace helper method, we calculated the optimal path, right? Optimal path that we have printed this one. We have already calculated, and that we have printed within the main method as well. So we are done with the logical part. The only thing is input output part is left. We have already made use of the fast scanner. This method, I'll just copy paste this method. This is related to only input output, basically input, right? So just give me a second here. So let me do one thing. Let me come here. Let me paste it over here, right? So we have got the fast scanner method. You can just go through this one. This is kind of template. I make use of many templates again. So this is one of the templates. This is fine. Now we're done with the coding part, right? So this is it for the problem. So we have discussed this one step by step correctly, right? So first a minimal path, this one minimum time, solve method, this one optimal path, trace method, then input output along with printing the minimal path, minimum time, and the optimal path within the main method. And finally, fast scanner, nothing but that is related to the optimal, this one, sorry, what do we call, input output, fast input output basically, right? So this is fine. Now, before checking the code with different inputs, let's check, let me copy paste the signature starter template, man. Just give me a second here. So I'll just come here, uh let me paste this one. This is fine, man. Now let's do one thing. Yeah, I'll just come here. So for this one we have to get the output 80120, right? So let me paste the this one input here. Let's check. So this one in number 20, this one has to be star. Let me run this one again. So yeah, we are getting 20210, right, instead of 8. So path is correct. 2 in the sense we have done something wrong within the solve, right? So let's check what we have done wrong within the solve. Let's see. So basically what we are doing in the solve here, first, if all the n objects are delivered, no more in the right, so bit count has to be equivalent to n plus 1. So here this is if integer dot um, bit count of mask. So this is fine. This if it is equivalent to n plus 1, then we have to return 0. This is correct. Then we are going with a simple if condition, nothing but we have to return the memoized answer, right? So that is the reason we are going with a dp of mask. If it is not equivalent to -1, then we are returning dp of mask. This is fine. We are initializing result here, nothing but we are going with a large initial value, right, as I've said. So this one has to be equivalent to the positive infinity basically. This is int result equals, we are converting this one to the int. This is fine. 10 to the power of 9 we are going, so 1e9. This is also fine, man. So we are picking the first not yet delivered object I, right? So I equals 1, I less than or equal to n, I plus plus if mask. So again, two brackets, this is also fine. Left shift operator I, if it is equivalent to 0, then let's go with a for loop here. J plus plus, so this is fine. Mask and 1 less than this one, left shift operator J. If it is equivalent to the value 0, then and new mask equals mask or 1 less than and cost equals solve of new mask plus distance of 0 I plus distance of solve of and this one 0 I. Oh, I have not given, so this one I have considered distance of 0 I. This is fine. Plus distance of, oh, I have not given distance of ij as well. I have not appended here distance of this one I comma j. That is the reason we were getting uh, a wrong answer basically for the minimal time, right? So this one also we have to append. This one here also I have copy pasted the same thing, I think. So this one here, let me copy the same thing here. Where is it? So within this one, int cost equals solve and distance. So this one has to be distance of I comma j. This one also we have to include, right? So now if I run this one, still get the same thing. Why? What is the mistake? So this one result mat.mon of result and cost. So this is fine. We are just breaking because this is nothing but the optimization part. We only have to branch on the first free I, right? So that is the reason we have made use of it. This is also fine. Finally, we are going with a, we are just memoizing using dp of mask and we are assigning this one to the result. So we are just memoizing and returning. This is also fine, man. So what is the mistake then? What I have done? Just give me a second here. So see here in the line number 31 basically, see within the distance method, so we are calculating the this one, right, squared distance, Euclidean squared distance, right? So here it has to be written dx plus into dx plus dy into dy, right? So this one I have written wrong, so that is the reason I think we are getting the wrong answer here, minimal time. So we run this one. I hope this, yeah, now we are getting the correct output, right? So we can either go with 801020 or 010, this one 0120, both works actually. right? So we have the multiple outputs for this one. So I said this one to you, either it can be within the this one output we got 0 1 0 2 0 for if we have considered j equals 1 and j equals to 2 for that path. Also we got a min of 8 comma 8, which was 8, and when we considered this one pair, right? So pair route, then also we got for that also we had got 8 basically, right? So we can consider either of them. The path was this one 0 1 0 0 1 2 0 for first one, and another one was 0 1 0 2 0. So this is giving us the another route, this one another optimal path 0 1 0 2 0, right? So this also works basically, right? So let me copy this one. So this works absolutely correct. So let's try it out for the second one. So we have to get 3210 something. So we are getting 32, which is correct. 12030 we are getting. So this is the only path, I guess, or this is the first path accordingly with the code we are getting. This is fine. So I insist you to try out for the second one, man. This one, second input. I insist you to try out for the second input. Yeah, in the same way that I showed for the example one or the first input, right? So you'll get to know the approach better, right? So this is fine. Now let me copy this entire thing. Let me come here. Let me hit the submit button. So this is fine. Let me come to the submission part. Let me paste it over here. Let me hit the submit. So I hope this works, man. Let's see. Let's wait for some time. So this is pure DP, man, right? Bit mask DP. This is fine. This is rated. Yeah, you can clearly see here in the tooltip it is showing accepted. Means see here the verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct for all the test cases. We have made use of two helper methods to calculate. First one, three helper methods basically, right? Including input output it is four. So from two I directly went to four. This is fine. Now main methods, helper methods are two basically, right? So this one solve and trace. Solve to calculate the minimal time, and trace to calculate the path, optimal path. And distance, dist whatever we have made use of, that is for the this one what do we call to calculate the square distance by making use of the Euclidean formula. And fast scanner, this one is purely related to the input output, right? So you can just make use of any template, man. So this is fine. This is nothing but we have successfully solved the problem using bit masking, nothing but DP along with the bit mask, right? So bit mask again, we are just masking the value. Bit masking is nothing but we will be masking the value um, just to keep that particular value, change it, or to modify it, right? So within the data. So that is the main this thing, if you want to go with the definition part basically, right? So that's what masking means, right? So bit masking, so we'll be dealing with the bits, right, and the binary representation. So same thing, bit masking is referred to masking the bits within the binary representation, right? In the binary representation, either to keep the particular data, right? So whether uh, to keep, whether to change or to modify the data in the binary representation, that's what we call bit masking, right? So we went for the bit mask DP here. This is fine. Now we are done with this part. What is the rating of this problem actually? 2000, right? So this is somewhat medium to hard question, right? So this is fine, man. So we are done with this particular problem. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.